Hi, so today I'm going to be talking about algebra, a little more specifically polynomial equations. Just to give a brief rundown of what I'm going to talk about, I'm going to first talk about briefly Babylonian algebra and contributions that they made to the discipline. Then I'm going to talk about Chinese contributions to algebra, including the mathematician Liu Hui. I hope I'm saying that correctly, or at least something close to it. Then I'm going to talk about some Islamic contributions to algebra, including Al-Khwarizmi and Brahmagupta. Then I'm going to talk about the solution to the cubic equation, specifically the Cardano, Tartaglia dispute and the solution that came out of that. Then I'm going to talk about some other important contributors to algebra, specifically Vieta, the French mathematician. And then I'm going to talk about some real-world applications of polynomials, including how we use them in our everyday lives, and a brief list of careers that use them on a daily basis. So, Babylonian algebra. Babylon was really devoted to mathematics, similar to that of the Greeks. They had methods to solve the quadratic equation, even before Al-Khwarizmi, who is seen as like the father of algebra, before he even discovered them, because they, of course, were a society that was alive before Al-Khwarizmi was. They could only solve equations with positive solutions, though, because they didn't recognize negative numbers. The Babylonians essentially set the standard for the rest of the world in the world of algebra. Chinese contributions to algebra. So the Chinese produced the first written transcript of algebra, which the title is Zhui Zhang Suan Shu, which translates to the 9 chapters of mathematical art. The book covered trade, taxes, engineering, all things that they would have used in their society. It served as a guide to solving equations using deduction and elimination, which is a similar system to that we use today of moving one thing from one side of the equations to the other and manipulating the equation until you get your answer. There is no single author accredited, so it is widely accepted that it was just a culmination of the best mathematical minds of the era. So, Liu Hui, he was a Chinese mathematician, and he is most famous for writing this commentary on the 9 chapters of mathematical art. Little is known about his personal life, but it is very evident that he was not of a lowly birth. He was more high class because he had access to a bunch of literature of the time, not just on mathematics, on science and novels, stuff like that. He was the first to propose the idea of decimals and the first to use them in his work. And he also did a lot of work in the areas of volume and area, but he didn't do a lot in the theoretical realm. He did more applicable math. His commentary on the 9 chapters is very important to the world of algebra and to polynomial equations. The original textbook just kind of gave instructions on how to get the answer with no clear explanation of what you were really doing, and it didn't have any proofs either. And Hui didn't really write proofs, he just wrote the explanations that led later mathematicians to write these proofs for the rest of the world. So, now, Islamic contributions to mathematics. Al-Khwarizmi, he was a mathematician, astronomer, and geographer, and he studied at the House of Wisdom in Baghdad, and that was just kind of a very central hub for science and math and just more enlightened learning. He wrote many minor works and was known for writing the horoscopes of important historical figures. He also gave mathematics the term algebra whenever he wrote his work Algebra wal Muqbala, which translates to the science of restoring an opposition. The word algebra means restoring. He also invented the idea of the algorithm, and the word algorithm actually comes from his name. Most of his work was in quadratics, and he worked mostly on practical problems rather than algebra as it's understood now, very similar to the Chinese doing more applicable math rather than theoretical. He found a general solution that worked on all quadratic equations. Now, Brahmagupta. Little is known about his personal life as well, just a product of the times, but he wrote a 25-chapter textbook entitled Brahma Sputra Siddhanta. And the first half of the textbook was about just common mathematical and astronomical theories of the time, and the second half was explanations of those theories, as well as a lot of algebra and various observations on calendars and such. He made the idea of multiplying large numbers using place values a little more commonplace. which is a system that we very much use, especially in mental math nowadays. He established an algorithm for square roots. He found formulas for the areas of triangles and cyclic quadrilaterals. He also established the quadratic equation, the x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That was primarily his work. Now, cubic equations. So far, most of the work in mathematics and polynomials has been done on quadratics, but around the 15th century, more work on cubic equations was done. Two major players on that were Cardano and Tartaglia. Cardano was born in 1501, and he received a formal education, and he was actually a medical doctor. But his life was full of tragedy despite all his hard work and despite his education. His sons were kind of hopeless. They were lowlifes. And he had a charge of heresy that he was exiled, and that punishment eventually drove him to insanity and killed him. Tartaglia was born in Italy in the beginning of the 16th century, so around the same time. And all of his mathematical education was self-taught. He was not from a rich family. He was very much, he was a self-taught mathematician. So, they have this famous little fight between them. So there was this mathematician named Del Toro, and he was working on the solution for a cubic equation. He actually found it. But before he could publish it, he died. And so his work never got seen or published, and he was never credited for it. So Cardano and Tartaglia, two major mathematics people during the time, they were both working to get this solution, and Tartaglia actually found it first. Tartaglia discovered the solution, and he was going around and he was using it, but he hadn't published it yet. And Cardano was working with his student Ferrari on this textbook. That would essentially be a mathematics textbook for people who wanted to learn the subject. And he sent letters to Tartaglia saying, will you please tell me the solution to cubics so it will be published? I promise you will get due credit. And Tartaglia refused and instead sent him this poem with the solution encrypted. And at first, Cardano and Ferrari couldn't really figure it out, but then they're like, hey, just give us a clue, and he did, and they figured it out. So they figure out this equation, and they publish it in the textbook without accrediting Tartaglia as the finder of this solution. And so, naturally, Tartaglia was not very happy about it. So he sent a series of, strongly worded letters to them, and eventually Ferrari got fed up. He was like, dude, come on. And so he challenged him to kind of a duel of mathematical wits. And they were doing all these equations, and they were doing cubic equations, naturally. And Tartaglia eventually just got fed up and left in like a rage. And he told everyone he won. Well, he left. So Ferrari kind of went by default. Cardano actually lost his teaching position. And Ferrari went on to solve the quartic equation, so we see who the real winner is in the situation. But we did get a solution for the cubic equation out of all this. So, essentially the theorem is that with an equation x cubed plus px is equal to q, then x is equal to u minus v as long as u cubed minus v cubed is equal to q, or 3uv is equal to p. So essentially, u cubed minus v cubed is equal to the constant of the original equation, and 3uv is equal to the coefficient of the term x. And you can prove this through substitution by just plugging in its systems of equations, essentially, and by plugging in you can prove that all this is true. So if you look at an example of the formula, one of the questions Cardano himself actually solved was x cubed plus 6x is equal to 20. And it's, like I said, it's systems of equations, so you solve for u and then you use that to solve for v. And it looks a lot harder than it is once you actually get going on it. So now onto Vieta. Vieta was a French mathematician of the 15th century, and he worked for a lot of really high-class royals. He was originally a lawyer, and so naturally he was very political. I mean, he worked for all these politicians. He was well-versed in the law, so he naturally had a lot of opinions on it. He disproved a lot of incorrect theories of the time, like the fact that a circle could be squared. and he wrote a book called In Artem Analyticum Isagoge. And he wrote the first algebraic notation where he used letters as variables. And that's one of the most major contributions that he made. He did a lot of work in other places, but in algebra specifically, his major contribution is the use of variables, because that's the system that we still use. His system for classifying variables is a little bit different than the one that we use, but ultimately his system catapulted the system that we use today. So some real-world applications of polynomials. Polynomials, we use them every day. We use them when we're shopping. You go to the store and you say, okay, I'm cooking this recipe, I need so many of this and so many of this, and they each cost this much. How much am I going to spend? Well, you use a polynomial, you use a linear equation in that situation. And a lot of people will also use polynomials when trying to find the depreciation value of a large investment, such as a car, to see if it's worth what they're going to pay for it in the long run. And just some careers that use polynomials: doctors, nurses, engineers, statisticians, teachers and professors, accountants, sales associates. They all use polynomials to do basic calculations during their mathematics. So I hope you enjoyed my presentation on polynomials. Hope you learned something, and thank you.